Hello class, in this example I'm going to show you how you can do probability problems from a small table of data. And I say small table of data only because this is a small table, but this can be done then for large data sets as well. This is how probabilities are found when people are sampled. So this is a good example of how probability is used in the real world. All right, so let's go ahead and read this scenario. 20 randomly selected individuals were asked whether or not they had a Twitter account. So they can respond either yes, I have a Twitter account, or no, I do not. And their age was also recorded. This was either recorded as 24 years old or younger, or 25 years old and older. So essentially there's a cutoff between 24 and 25. And so this then table records then their responses for each of the individuals. So let's suppose we want to find some probabilities. If a person from this group was selected at random, what is the likelihood they would have a Twitter account? Well, how can we find this? Well, essentially the probability of having a Twitter account, let's just call this T, I'm going to call Twitter T, is then equal to then the total number of people who have a Twitter account. So we can just count these up. So it's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 of the 20 individuals have a Twitter account. This turns out to be 0.6, or in other words, 60%. So 60% of those selected have a Twitter account. Or you can think of this, if a person was randomly selected, the likelihood they would have a Twitter account is 60%. Okay, so again, probabilities are all just about counting up the number of events that apply in my scenario over the total number of events. So if I want to find the probability a randomly chosen student is 25 years or older, I can do kind of the same thing. So B is then the probability of, and I'm going to call this 25 plus, so 25 or older, is then simply just then equal to 1, 2, 3, 4, 5, keep counting these up, and I get 11 out of the 20 people that were selected are 25 are older. Okay, this turns out to be 0.55, or in other words, 55%. So this is really kind of the very root of probability, essentially looking at the number of events that apply over the total number of events. So we can extend this into intersections as well. So what would be the chance that I would randomly select a 25-year-old or older that has a Twitter account? So how we can find this is we actually just look up the people who have a Twitter account and are 25 years old. So we can easily see that this would be these 5 people. They're 25 years or older and they have a Twitter account. So 1, 2, 3, 4, 5 of these people apply to what I'm interested in. So if I wanted to write this in notation, that'd be the probability of 25 plus and Twitter, which I'm going to call T in this case. This is again equal to then 5 out of the 20 people. And so if I were to randomly select someone, the chance that they would be 25 years old or older and they had a Twitter account would then be 0.25, or in other words, 25%. All right, so I can keep going, but now what if I want to do a conditional statement? So let's suppose instead of doing an intersection, I want to find the probability someone has a Twitter account given they were 25 years old or older. So I'm going to then minimize my sample space to only the people who are 25 years old or older, because this is then my given. So I know that I haven't selected one of these people. I'm saying now I know that it's of these 25 years old or older individuals, and then what's the likelihood of these people that they have a Twitter account? Well, we can see that that's 5 out of the 11 people that have that. But let's go ahead and write it in notation. So what this means is the probability of Twitter given 25 or older is then equal to, then in my denominator, this is the biggest difference. This is the biggest change in a conditional distribution, is that now I don't have the entire sample space. I don't care about all of the 20 people. I only care about the 11 in my given sample, because I already know that somebody is 25 years old or older, so that's out of the 11 individuals who are 25 years old or older, how many of those have the Twitter account? Well, this is then the 25 plus the 25 and over and the Twitter account. So we know that that's the 5 people. So 5 over 11 is my answer. This comes out to be about 0.4545 repeating. And essentially we can just say that this is about 45.5%. All right, so we can do that same type of thing for E. If we want to find then the probability of having a Twitter account given they're 24 years old or younger, so I'm going to write this as 24 minus, is then equal to, well, however many 24 years old or younger individuals that were sampled, and we could count these up to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Now see, again, I don't care about the entire sample space. I only care about the given, the 24 years old or younger. And so my denominator will become the likelihood of obtaining a 24-year-old or younger person, and my numerator will then be then the number of events that apply in then this given category. So that's 1, 2, 3, 4, 5, 6, 7. So 7/9, which is about 77.8%. So it looks like having a Twitter account and age are not independent of each other, because it looks like if you're 25 or older, the likelihood you have a Twitter account is actually a lot smaller than if you're 24 or younger. So that's just something that's kind of interesting, and something that is usually done to be able to see if there is a kind of difference between age groups or some sort of category. Conditional probabilities allow us to compare those really nicely. Okay, so there's one more thing that we want to do in this video or in this example, is that we want to create a Venn diagram of this situation. So how could we do that? And that's kind of a hard thing to conceptualize, but once we've calculated out some of these probabilities, it actually isn't too bad. So let's go ahead and scroll down a little bit. And we always start off when we draw our Venn diagrams with our entire sample space. We've got our big box, and maybe we want to draw a large circle for our 25 plus group. And it doesn't really matter which one you choose, 25 plus or 24 minus. It doesn't matter. It will give you the same information, just look a little bit different. Then we want to do a circle for the Twitter account. Call this T. And of course, we already know the intersection of these two. So remember that thing in the middle there is basically those who have a Twitter account and are 25 or older. Well, we actually have that probability. It's right over here, 0.25 or 25%. So let's go ahead and write that inside, 0.25. Remember, when we do Venn diagrams, we always start in the intersection and move our way out. That way our whole sample space adds to 1. So here our intersection is 0.25. That means then the entire circle of Twitter is equal to 0.6. So this area right in here then is equal to 0.35. So our whole circle is 0.60 for Twitter, and then the entire circle for 25 plus, so those who are 25 years and older, is 55%. So that means that those who are 25 and older and don't have a Twitter account is 30%. Okay, and then lastly, who are the individuals out here? Those who do not have a Twitter account and who are not 25 years old or older. Well, essentially, those are the 24-year-olds or youngers and those who don't have a Twitter account. So they're out here. This is the leftover of 0.10. We can see that this is then 2 out of the 20, which is 0.1, but we can also see that this makes sense with our Venn diagram, because if we add up these values, they add then to 0.90. And so the leftover, these are then the 24-year-olds without a Twitter account, ends up being 10%. So let's do one more thing. Let's talk about this Venn diagram for a second, essentially what each portion means. So I just told you that this is then the 24-year-olds, 24 and below, with no Twitter accounts. This area in here is then those who are 24 years old or younger and have a Twitter account. So they're in here because they're essentially, it's like those who are not 25 years old and older and have a Twitter account are in here, and that's 35% of the total. And you could actually calculate that here too. You'd add up 1, 2, 3, 4, 5, 6, 7 out of 20 will also give you 0.35. And then again, this is the intersection of 25 and older and having a Twitter account. And lastly, this little group here is the 25 and older who then don't have a Twitter account. And you could count that up by saying, okay, these are these people, 1, 2, 3, 4, 5, 6 out of the 20 would also give me that 0.3. So this Venn diagram should match up with and make sense with all the data here, but it's a really nice kind of little summarization rather than using this table. Hopefully this video helped you understand how to summarize data from a table to then complete probability problems.